So let's consider an example with a chainsaw. So if you have a chainsaw, the idea of the chainsaw is you've got a sprocket here, and the sprocket is connected to a chain. Okay. And so the chain kind of goes down a bar and comes back. And so as the sprocket turns, it moves the chain. Well, the chain has the little cutting bits on it, so that acts like a saw. Okay. I guess the cutting bits actually go that way. Okay, so let's say that the sprocket here has a radius of 1.25 inches, and let's say that the sprocket spins at 250 RPM. Okay, so I want to know actually how fast is the chain moving right here. Okay, so how fast does the chain move? Well, we know that's going to be R times omega. Now, the thing is, this is only true if omega is radians per second. This does not hold unless it's radians per second. Likewise, the distance equals R theta only holds if that's in radians. It does not hold if that is not in radians. So we need to be careful here. So we need to convert 250 revolutions per minute into radians per second. Well, we just do it the same way we did the previous problem, and that comes out to be 26.2 radians per second. So V is R omega, so that's going to be equal to 1.25 inches times 26.2 radians per second. So that comes out to be 32.7 inches per second. Now, normally you don't actually do inches per second. We normally do feet per second. So if you divide by 12 inches per foot, then this comes out to be 2.73 feet per second. So that would be the rotational, that'd be the linear speed of that chain. So for the chain, you got the sprocket here, you got the bar, you got the chain running around it, and so this is spinning and the chain's going around, so the chain is moving at 2.73 feet per second. So now, if you take your chainsaw, however, and you are sawing through something, if it takes 35.1 seconds to saw through, the question is, how far did a piece of that chain move distance-wise? Well, the distance is going to be R times theta. Well, theta, if you're going at constant speed, remember theta equals theta naught plus omega naught t plus 1/2 alpha t squared. If you're going at constant speed, theta is just going to be omega naught times time. Okay. And so that means that this would be R times omega naught times time. Okay. Well, in that case, then we would simply say that this is going to be equal to, now there's two ways of doing this. Okay, we have the R, which is 1.25 inches, 25 inches, times the omega, which is 26.2 radians per second, times 35.1 seconds. And so that is going to come out to be, basically 1150 inches. Okay, so we can convert that into feet, and that comes out to be 95.8 feet. There's an alternate way of solving the problem, because I already said that the linear speed was r times omega, and we said that that was 2.73 feet per second. So I could just say x is going to be equal to velocity times time, because again the acceleration is 0, and if I do that, that comes out to be 2.73 feet per second times 35.1 seconds. That comes out to be 95.8 feet. The exact same number. Well, of course it's the same number because it's the same problem. It's just two ways of getting the same answer. And again, I don't really care which way you do it because they both actually are equivalent to each other. So just thought I'd give you both ways of solving the problem.